Welcome back to Day 0 to Breakthrough. It's Day 9 and I'm joining Diego, Nick and Keith to discuss how their vaccine technology is going to help us conquer chappare mammarenavirus. When you're exposed to a pathogen for the first time, you tend to get sick. But every time after that, your body builds a better and better immune response, so you don't tend to feel as ill. This is because your immune system produces antibodies, which are tiny proteins that bind to the virus or bacteria and block them from entering your cells, among other things. A vaccine helps your body learn to fight an infection without the dangers associated with actually getting the virus or disease. The goal of a well-designed vaccine antigen is that your body will recognize it and produce what we call a neutralizing immune response. A neutralizing response simply means the antibodies your body produces against the virus will physically block it from binding and entering your cells. UQ's Clamp2 technology is what we call a subunit vaccine, which means they take a tiny protein fragment from the virus and attach their clamp to the end of it. This improves the stability of the vaccine and is really important for its function, which we'll get to shortly. The protein they're taking from chappare mammarenavirus is called the fusion protein, which helps the virus bind to our cells and enter into them, which is what causes infection. So, Keith tells me this is the best protein we can target to develop an effective vaccine.
If the virus can't attach to a host cell, then it can't get in, it can't start the infection cycle, and it can't cause disease.
What surprised me about the Clamp2 technology is that they can build this vaccine and take that protein fragment without ever touching the virus itself. They do it all just from the genetic code of the virus. The viral fusion protein comes in two shapes, or conformations, and it switches between them. First, we have the pre-fusion conformation, which is the shape it's in when it's ready to bind and help the virus enter cells. Once it's bound, it changes shape, forming the post-fusion conformation. Diego has a helpful analogy to explain what this does.
Viral fusion proteins are a bit like mouse traps. They're like spring-loaded and are ready to release the energy to allow the virus to enter the cell. So the pre-fusion is a mousetrap ready to spring, and then post-fusion is after the mousetrap stopped working, practically when it clicked.
Clamp2 plays an important role in keeping the viral fusion protein in its pre-fusion conformation, which is really important for vaccine effectiveness in providing that neutralizing response.
So we want to freeze the antigen in this pre-fusion conformation. When it's in pre-fusion conformation, it's when it's at its highest chance of developing an immune response that will stop the virus. The post-fusion is not as good as an antigen. That is why the clamp is important.
An antigen is simply something your body produces an immune response against. It could be cats, it could be dust, it could be peanuts, or it could be a vaccine. I was a bit confused about how Clamp2 was able to do this, so I asked Nick and Diego to explain it a little bit more. They came up with a really helpful analogy to explain what Clamp2 is doing as it keeps the antigen in its pre-fusion conformation. Nick and Diego explained that the viral fusion protein is like a bouquet of flowers, and your hand is the clamp.
As you present the bouquet to a person, and you want the flowers to be compact and kept well arranged, the same happens or works for the antigen. This viral fusion protein has to be presented to the immune system in a way that makes it so that when the virus then enters the body, it's in the same conformation, and we can have an immune response to that specific conformation of the protein.
I don't know about you, that was a lot of information. The important thing to take away is that Clamp2 is really important for developing a vaccine that's protective against chappare mammarenavirus. Next time we check in, the team hopes the last of the materials they need to start building their vaccine candidates will have arrived, and they'll be well on their way from Day 0 to Breakthrough.